Okay, so question 13 now. So the following is an attempted proof of the conjecture blah blah. Okay, if tan theta greater than 0, then sine plus cosine greater than 1. Okay, I'm not sure if that's true or not actually. So suppose that tan theta greater than 0, so in particular cosine theta is not 0. Okay, so basically we have to find if the proof is correct or not, right? Okay, so let's look at the first line. Since tan equals to sine over cosine, okay, well, I can't disagree with that. Then sine times cosine equals to tan times cosine squared theta. That is right, and that's greater than 0. Okay, do we agree with that? Yes, right, because I'm multiplying cosine squared either side. I'm multiplying cosine squared either side, right? That means that I'm multiplying by a positive number either side. So, because tan theta was greater than 0, that was our setting, right? That was our setting here, right? So that's why this is okay. Got it. Okay. Next line. It follows that 1 plus 2 sine cos is greater than 1. Okay, now because sine cosine is greater than 0, right? Sine cosine is greater than 0. So we're saying that 1 plus something greater than 0 is greater than 1. Oh, makes sense. Makes perfect sense, right? Fine. Okay, next line. Therefore, sine squared plus 2 sine cos plus cosine squared greater than 1. Now, that's also perfectly fine. I can't disagree, right? Because it's an identity. You can never disagree with identities, please. Okay, so this one's okay. Which factorizes to give, well, I'm just factorizing things. So again, I'm doing something legit. That's fine. Therefore, sine theta plus cosine theta is greater than 1. Okay, now, I think there's some problem with this one, right? Because, you're square rooting both sides. Right, square rooting both sides is a never good thing, right? Suppose today, this is minus 3/4, this is minus 3/4 as well. Well, then you're in trouble, right? Or okay, I suppose you can't be minus 3/4 at the same time, but you get the idea, right? Just make something up such that both are negative, and it makes something sensible, right? Chuck in some sensible values. Then this is not true, right? Because if sine plus cosine was negative, then you're in trouble. I hope we realize that, right? So for inequalities, please never square root both sides, okay? And but just play safe, right? Just play safe, and then do things properly, okay? So this is not a good proof, right? Because it takes square roots both sides, okay? So we're saying that the proof is incorrect, right? And the first error occurs in line 5. All right. Hopefully we follow that.